Welcome, everybody. Welcome to the age of the super subconscious, encounters of the third kind with the multimodal generative AI revolution. It's a pleasure being with all of you here, Javier Ideami. And we're going to do a fascinating journey together about what it means, what it does, applications and limitations of this generative AI revolution. A little context about myself, a couple of recent projects. One of them, the Geniverse, which was one of the very first generative AI platforms launched in the world. When at the beginning, when there was almost nothing, and now everything has gone crazy. Another one, the Lost Landscape project, about high resolution visualizations of the lost landscapes of neural networks. Those are two of the recent projects, and we're going to begin this journey. Let's go for it. Lots to cover. And in this journey, we're going to explore, first of all, the essence of this revolution, doing some analogies and parallels between what goes on within these AI architectures and within our human brain. So, first of all, let's think that we all live in an ocean. It's an ocean of what? Of information, of complexity, too much information. So both in AI architectures and in our brains, we have to somehow simplify. We have to somehow compress all of this complexity. And so we create these processes, these funnels that compress the complexity, and they take us basically from high detail to high abstraction. We take all of that detail and we compress it into a more abstract representation. This that you see here is a metaphor I very often use. It is like a pot, it's like a kitchen pot, and I use it to represent our subconscious. That is where all of these compressed representations go, and these compressed representations, they produce what we call also latent expressions and latent spaces of all of that complexity. And then we can also do the opposite process, decompression. So we compress all the complexity, we go from high detail to high abstraction, we create that bottleneck, that latent space, and then we can do the opposite and decompress and inflate and go from all of that high abstraction back to the high dimensionality again and the high detail. So in this representation, you can see, well, our consciousness, that is so mysterious, and then this subconscious pot where we combine and recombine and we cook and we mix all of these compressed representations. And so we have this bidirectional funnel. We take the complexity, we compress it onto this latent bottleneck, and then we decompress and inflate back to the high dimensionality. And so these compression and decompression processes with this latent bottleneck in the middle is really at the essence and at the base of all that is going on within both our minds and these AI architectures. Another metaphor that I created and that I use very often is the depth elevator metaphor. So you imagine a vertical axis with an elevator, and at the bottom we have detail, high detail, and at the top we have high abstraction. So in our human mind, we are constantly moving in this axis, So when you tell me, some phrase with language that is basically a high abstraction, and I visualize an image in my mind, I'm going down, to the high dimensionality from high abstraction to detail, and the opposite, right? When we can go also from that, we can look at an image, and express it verbally, and go from the high detail to the high abstraction. Now, these compression and decompression processes, they provide not only an advantage in reducing complexity and amount of information, but also in basically creating data that is more relevant and useful. If we look at the image of this insect on the left, if we think about it, this is very high dimensional data, right? Millions of dimensions in an image. Now, but what is the point of knowing, for example, that one point of this image has 155 value of green intensity? It's really useless information. It's not very useful. But if we take all of those millions of dimensions and we compress them into just 50 or 100 factors, and each of those dimensions or factors expresses something really useful and relevant, like, for example, what is the shape of the body of the creature, how many wings it has, something about the color of the skin of this insect, etc., then this is way more relevant data. So we do these compression processes not just to reduce the complexity, but also to basically work and to basically isolate factors that are way more relevant and useful regarding the domain of information that we are working with. And then once we have again that bottleneck, right, and we have those small amount of factors and dimensions that express the essence of that domain of information, we can decompress and do the opposite process and invent or regenerate or generate something completely new. Here we have a collection of these subconscious spots. We are one of those, and we are surrounded by many others. And this infographic, it shows us that there is this connection, right, between that top and bottom part of the depth elevator, so that the good thing about abstraction is that abstraction allows us to then interconnect many of the things that are happening at the bottom of that depth elevator. Okay, this is an infographic that is going to tell us how DALI 2 works. So DALI 2 is one of these generative AI systems, and we're going to do an analogy between the human brain and DALI 2. So the first step in DALI 2 is that, we type a phrase, for example, an illustration of a unicorn wearing sunglasses surfing a wave digital art. Or in our human scenario, somebody tells us, hey, visualize an illustration of a unicorn wearing sunglasses and surfing a wave. Okay, in the case of DALI 2, the first thing is that this text is going to enter an encoder architecture. This is an AI model that is going to compress, that that data into, again, a compressed latent representation that is going to just, preserve the essence of that text, And for that, DALI 2 uses the CLIP architecture. CLIP was a model created by OpenAI that has been trained with hundreds of thousands of pairs of images and texts. And it has learned basically to create a latent mathematical space where the compressed representations of images and texts that are good matches with each other are located close to each other within that latent mathematical space. So it uses this architecture to produce this compressed representation. Now, in the case of the human beings, we listen with our ear, that phrase that they tell us, and our brain is going to do the same. It's going to have different layers in the brain that are going to gradually abstract that sensorial data. For example, we know a lot about how this works regarding the visual cortex in the brain. We have actually seen how through different layers, those inputs basically become more and more abstract. And the same is going to happen, regarding different senses. Now, the intermediate stage regarding DALI 2 uses this intermediate architectural model that they call the prior, and it uses a diffusion model strategy. And basically what it's going to do is going to translate between modalities. It's going to pick the compressed representation of the text, and it's going to use it to try to predict what would be the compressed semantics, the compressed representation of a potential image that would match with that text. That's what it's going to do. And in the brain, it's going to be a little bit the same. We're going to have, obviously, some translation between modalities. That's why, we can look at an image and think of some music, or, we can read something and visualize something. There is this translation between modalities. This is the, high-level way of thinking about it. And then finally, the last stage is really the generative stage. In DALI 2, we're going to take that, predicted semantics of the image, and we're going to put it through a generator that also uses a diffusion model. And that generator is going to inflate it. It's going to go from that abstraction, compressed abstraction, back to the depth elevator, back to the high dimensionality and the high detail, and it's going to, create a new image. And in the case of human beings, we have, obviously, internally, we have that compressed representation, and then it gets decompressed as well, and we visualize an image in our minds. Now, in the case of AI, it's using a diffusion strategy. So the way diffusion architectures or models work is very easy to understand at a high level. The way they are trained is that you take an image and you add noise to it, Gaussian noise, and more and more amounts of noise until the image becomes complete noise. And then basically you train the network so that it learns to go from different combinations of an image plus different amounts of noise back to the original image. And you do this with many, many different images. And after you have trained this with many, many different images, then the network is able to go basically from either a noisy image or pure noise back to a fully recreated image. Okay, and also in the human brain, when we visualize something, you will notice that if I tell you to visualize an elephant cooking something in a kitchen, every time you visualize it is a little bit different and things pop in and out. There are holes, there are gaps. There is this noisy stochastic environment. And also remember that we are going from a bottleneck back to the high dimensionality. So because of that, because we go from a bottleneck to the high dimensionality, this allows us to create many different variations because there are many different ways in which you can go from a compressed bottleneck representation back to the high dimensionality. Within the AI architectures, there are ways to actually make the process deterministic, but in the case of our brain, this is a more stochastic and noisy process. Now, you can download this infographic from this link for free. All right, so let's continue. So generative AI, for me, the mantra that I use very often is coming home. Why? Because the further we go with generative AI, the closer we get to what? To our own essence as beings that are able not only to converge, but also to diverge. Because we have gone in the last years through the convergent phase of AI. We have really improved in our capability of predicting, recommending, classifying, and now we come home because now with generative AI, with the generative AI revolution, we're able to combine divergence and convergence, compression and decompression, exploration and exploitation, and very important, in a multimodal way. So precision entropy, we predict, classify, recommend, but also now imagine, augment, and create. And will this take us to AGI, to artificial general intelligence? Well, that's an open question. We'll talk about that later. But so, as human beings, you and me, our perception is a generative model trained to produce simulations of our environment that fit with what's going to happen. So basically, we are all the time in life, we have this simulation, this generative capability in the brain that is trying to all the time simulate what's going to happen. And then we observe what happens, and the difference between both things gives us a difference signal, an error signal, a loss that allows us to act on the world. And now, for the first time, thanks to the generative AI revolution, we are sort of closing the loop of all these capabilities. We are coming home. We are meeting in the middle of this ocean of complexity where we survive by compressing and decompressing, by abstracting the world and reinventing it, regenerating it as needed. So remember, these bidirectional funnels, flexible funnels that have these bottlenecks in the middle are really the base essence of complex beings like us and of successful AI architectures. And in these models, we use these latent compressed representation spaces, whose again function is to preserve the abstract essence of whatever information or domain of information in an efficient and effective way. Many times I also use this picture to put the example of, when you are describing a friend to another person, and again, you do this compression and decompression processes. And from those compressed latent representations, we can then reinvent, reimagine, and regenerate. But it is also very important, the quality of these latent spaces. Now, what goes on in those latent representations within our brain, we still have many question marks about those. But in AI, we are working to make them more efficient. An example, for example, if you compress those millions of dimensions into just 50 or 100, it is very important to see how separable, how overlapped are those different latent dimensions. Because imagine that you want to influence, a certain dimension, but not affect the others. So how separable or overlapped with each other are, this is a very important thing as an example. Okay? So we are expanding our home. And, I like to use more the term augmented intelligence rather than artificial intelligence, because for me, AI is not about anything artificial. AI for me is a journey and an exploration about ourselves, about our capacity to learn and to create. And so I like to think about more the term augmented. And now, what is the role of generative AI in this expanded home? Well, for me, generative AI is basically continuing a process of demystification that has been going on throughout history. At some point, we thought we were the center of the universe. We found out that that's not the case. At some point, we thought we were very, very different to the rest of the animal kingdom, and we found out that's not really the case. So throughout many centuries, we discovered, imagined, connected. Then we came to that was like the whole history of the universe in 5 seconds. Okay, so now we arrive to the generative AI revolution that has gone crazy in the last year, and there you have already my prediction for GPT-5 in a few years. And so what's happening here? That generative AI is also demystifying what? Is demystifying the human creative process. Because many people thought and think that creativity is like magic, but as Thomas Edison told us, genius is 99% perspiration, 1% inspiration. What does this mean? 99% what? Exploration, experimentation, combination, recombination, a lot of which takes place subconsciously in our minds. And 1% inspiration, planting the seeds, refining the results. So a lot of this 99% that is so important in the creative process, all that part that is mixing, combining, recombining, experimenting, a lot of it takes place in our subconscious pot. And there are, to really go deep into this, we're going to connect with Nobel Prize Daniel Kahneman, that has very famously written about different ways of processing information in our brains that he calls System 1 and System 2. System 1 is basically the way of processing information that is more intuitive, fast, mainly subconscious, parallel, non-linguistic, habitual, implicit knowledge. This is really what current deep learning is mastering and where it is achieving superhuman capabilities in so many ways. And then we have system 2 thinking, that is the slow, logical, sequential, mainly conscious, linguistic, algorithmic, that involves sequences, planning, reasoning, explicit knowledge. And this is the area that is still beyond current AI. So, and again, a good way to understand the difference between both is if you think about learning to drive or learning to play piano or learning to play tennis. At the beginning, you have to pay very close attention. You have to go slowly through the steps of that task. Again, sequential, slowly, consciously, pay attention. And once you have learned well, then it becomes subconscious. It becomes automatic. It becomes very fast. So that's the difference between System 1 and System 2. And there are many studies like this one of Huawei that tell us that human beings take around 35,000 decisions per day, and we're only aware of 0.24% of them. What does this mean? It means that we live way more than we think in semi-autopilot or autopilot mode. Most of our lives, in fact, takes place subconsciously, which is System 1. So generative AI is closing the loop of System 1 capabilities that go beyond what humans can achieve. It demystifies the human creative process, and a lot of that process is System 1, subconscious. So creativity is a lot of it, combination and recombination, not all of it, but a lot of it within latent spaces driven by System 1 processing. And generative AI is showing us what is possible when we do that big chunk of the creative process faster and deeper than humans can. And that's why, my friends, I call this new age that we are all living the age of the super subconscious. And I also want you to think that some people are scared of this new age. I tell you, do not be scared. Think of generative AI architectures as Iron Man suits that you're going to wear and that will amplify our subconscious pods and our creative muscles and capabilities. This is a win-win process because these Iron Man suits, there will be many of them with different capabilities and potentials. They will basically make our creative process more agile, faster and better, but they will also strengthen our creative muscles and will enrich our subconscious pods. Because when we work with generative AI, remember, current deep learning is basically mastering System 1, not System 2. So we still need to guide it, and we guide it with prompts. Prompts are inputs, guides to tell the AI what to do, in what direction to go. And that's why we are also beginning the age of prompt engineering. And we will soon see a lot of prompt engineers and prompt specialists. And we will see books and courses. And this will become a very sought after role in the job market. And so this is a win-win process, because already many people that are doing prompt engineering nowadays, they report that by doing it, they also feel that their creative muscles are becoming stronger. So it's a win-win process. And so generative AI becomes a companion, potentially a very interesting companion. We are already seeing a lot of reports of people saying that their interaction with large language models, sometimes it feels more interesting than interacting with other fellow human beings, even though it is just all system one. It's system one, but humans will fall in love with these systems. It's already happening. But what about system two? Well, there are all sorts of opinions. Some people think that system two is already here, like that famous Google engineer, that AI is already semi-conscious. I do not agree with this. Some people think that we need more progress in AI architectures and paradigms, like, for example, hybrid systems that combine discrete and continuous approaches to get there. Some other people think that we will never reach system two because it requires something that goes beyond our capabilities, like, for example, quantum effects, etc. In summary, nobody knows, but we know some things. For example, we know that volume matters. We know that as we have increased scale and data and volume, many architectures like GPT and others have improved dramatically, not only in quantitative ways, but also qualitatively. We also know that better architectures like the Transformer has revolutionized the entire generative AI landscape. Better architectures, they keep improving also the AI systems and taking system one further and further. Now, we don't know exactly what separates system one and two in the brain. So will system two capabilities emerge from advanced system one capabilities? Or will we need some kind of hybrid system combining different paradigms, both in AI and also that may happen in the brain? We don't know. Now, regarding volume, by the way, it's very interesting to look at this talk of the great scientist Robert Sapolsky, where he talks about the genetic differences regarding our nervous system between chimpanzees and humans. And basically, just to cut it short, what it says is that the only relevant difference regarding the nervous system is that we have 3 times more neurons. So again, the scale, the volume, this has been demonstrated. Volume and scale matter, and they work qualitatively, not only quantitatively. But they are not enough. Architectures and paradigms are also crucial, and they must keep improving. Also interesting to read the bitter lesson essay from Rich Sutton, one of the godfathers of reinforcement learning. Now, this is a very detailed infographic about how transformers work that I published, and also you can download it in very, very high resolution for free on this link. Let's continue. But this system 2 thing, it's not really that important. It doesn't really matter much. Why not? Because if we keep taking current system 1 paradigms further and further with more volume, more data, more scale, but also improving the architectures more and more, we will keep going further in qualitative and quantitative ways. And we'll probably find unexpected surprises around the corner as we keep moving ahead. I really recommend this wonderful book of Professor Kenneth Stanley, Why Greatness Cannot Be Planned, wonderful book. And Professor Kenneth Stanley tells us that when we are looking at a very ambitious goal like AGI or System 2 capabilities, the stepping stones to get there are typically nothing like the final goal. They are very difficult to predict. And so instead of following an objective gradient, it would be better to follow what he calls a gradient of interestingness. All right, this is very interesting. Now, it's also very interesting to connect neuroscience with deep learning and to continue being inspired by neuroscience research to keep improving our architectures in AI. An example is the work done by Jeff Hawkins and Numenta regarding sparsity of activations, temporal dynamics, etc. This could help us to reduce the power consumption of these generative AI architectures, make more resilient networks, etc. In connection with this, in 2021, I published this article in Towards Data Science in Medium. It was like the most read article in that publication in 2021, and you can download it and read it for free, or you can read it for free. If you go to this link, ideami.com/Numenta, it will take you to the free link if you want to read it. Now, who are going to be the market winners of this revolution? Okay, first of all, the companies that provide powerful infrastructure, APIs, datasets, etc., like OpenAI, Google, etc., these are going to be winners. Now, second, until now we've had like very generic platforms like Geniverse, for example, but now the winners are going to be, with the amount of people that are coming onto stage, the companies that produce interfaces that help people guide and interact with generative AI in relation to specific communities and their specific needs, providing functionality that adapts to those needs. And this is already quickly happening as we speak. And finally, open source or hybrid projects, organizations that work very closely with the AI community, like Stability.ai or Hugging Face. These are organizations that, they typically have some proprietary side and some open source side, but what they are doing very, very well is that they are working very closely with the community. Why is this so important? Because generative AI is moving so fast, that even during this talk, probably people are launching like dozens of new applications and platforms. That crazy it is. Okay, so it's moving so fast that a single company or group cannot keep track of everything. So working very closely with the AI community is absolutely crucial. And so who are the players in this thing? Okay, this is crazy now. My friends, the players are changing all the time. So this slide is completely irrelevant now. Okay, well, generative AI, stable diffusion, DALI 2, imaging, blah, 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 multimodal, multitask, Flamingo, Gato, some examples, and other platforms, Midjourney, Geniverse, Night Cafe. Yeah, but then, people are launching like, these infographics about just the players in the games market map. Okay, now by vertical, and now just more global. Okay, now there are too many players already, and more are coming on stage every week. Now, what are the applications? But before we go to these applications, a lot of them are focused on prototyping phases in general. Before that, let's talk about this very important issue, copyright. The copyright of what you produce. Now, no clear consensus, waiting for regulation, but in general, it is accepted that whatever you produce with these generative AI platforms, that's what the platforms typically say, you can use it commercially, but you should take care to avoid using generations that contain recognizable human faces, parts of brands, or other content that may have associated IP. But again, it's all very, fluid at the moment, and, regulation will probably enter this stage pretty soon. But something very interesting to talk about is the responsible AI movement, a movement that is all about making responsible use of this technology. And in connection with that, an example is the CAI, the Content Authenticity Initiative by Adobe, that Adobe actually began in 2019, and now is becoming really, really dynamic in connection with generative AI. It's all about bringing a lot of companies together. It's free to join to produce an open industry standard for content authenticity and provenance. Basically, they are going to provide open source tools that will allow you to track the provenance and attribution of digital content. Basically, we will be able to know where digital content comes from, if generative AI has been used to produce it or not, etc., etc. And they have provisions, of course, to protect the privacy of people involved in this process. This is important, okay? And there is a lot of discussion about this, and I have written a very extensive article about this in Medium very recently, and if you want to read it, you have the free link also to read it. If you go to ideami.com/generative, you will get the free link to read this very long article about this issue. Now, there are challenges. Yes, there are challenges. The typical ones that we know: deep fakes, truth obfuscation, spam, security and privacy issues, job market issues. And, we could go like hours about this. But let's go now to the application. Some examples, Okay, we have like a Macedonia of possibilities. Text to image, image to image, text to video. Text to video is beginning now. Text to 3D is beginning now. 3D reconstructions, AR and VR environments, experiments are beginning as well. And we have a lot of verticals. Some examples. People are using this technology already to produce branding assets, logotypes, etc. Character design, you want to create a character for a video game. Well, you could prototype lots of different possibilities with this technology and then produce and, work with the ones that you like. Now, digital art is an obvious one, illustration as well, cartoons as well. Now, this is an interesting one, food art. You can pick a niche like food art and imagine the investment to actually produce these things for real, right? But you can experiment with all sorts of crazy ideas with generative AI, and when you find things that are interesting, then you can produce them for real, or you can use this for branding as well. Very interesting. Now, fashion and jewelry are very good examples. You can take a mannequin or a person and you can try different costumes on the person with generative AI. This has a lot of potential, and you can go crazy, again, producing a lot of variations of jewelry designs that it would be obviously expensive to produce for real. And when when you create a catalog that you like, then you can send it to production. Now, scientific images is very interesting because many times in medical data sets, there is not enough data, and you can use generative AI basically to augment data sets, to augment data sets with synthetic generations that are going to create variations of existing data to augment your data sets. This is very useful. Now, product design, a lamp with the shape of a flower. This is very useful as well. You can go crazy experimenting all sorts of variations of a product until you are happy and you move on to produce it. Stock images is it's an obvious one, and the latest in this field is that companies like Shutterstock and Getty and others are starting to already incorporate generative AI in their services. Running. Why? Because they were obviously very worried, because if they did nothing, a lot of startups would take over the stock image space. So they saw the ears to the wolf, and they said, oh no, we have to get there first. So immediately they have started doing agreements with companies like OpenAI and to basically integrate generative AI quickly into their platforms before startups take over the space. Yes. Brainstorming prototypes. This is a very, very important one. You can take anything alive, every little thing, whatever this is the thing that you use to open the cans, and you can just go crazy, trying different variations of them, until again you find something interesting that you want to work with, drawing and sketching. Now, video. Unfortunately, these videos were playing, but when I have put them into StreamYard, they don't play. So I will have to narrate them for you. But yeah, video is beginning, text to video. So this is make a video by Meta. You give it a prompt, a phrase, and it's going to create a few seconds of a video that express that prompt. And it's really great. It's really great. Still, low resolution, but this is beginning now. But the one that I really like is Fenaki. Fenaki.video was launched very recently by Google. And now this is very impressive. It's very low resolution still. Now this will improve very quickly, but what is impressive is that with Fenaki you can give it a list of many prompts, many phrases, okay? And it will produce a video not of a few seconds, but of minutes, and it will seamlessly connect the visual expression of each of the prompts in video, in movement, with each other. So you get like a video of many minutes that is like a movie that is seamless, and it expresses a list of many prompts. And of course, this is the beginning, okay, of the potential future scenario where we will create movies and videos by describing them, like long ones, Of course, I thought this was going to begin in a few years, but it's already beginning now. This is how crazy things are becoming. Now, 3D, AR, and VR, we are already beginning to see the first text to 3D models. Dream Fusion is one of them. They are still quite limited. You can create little 3D models of a pineapple or something like that. Still quite limited, but they will improve fast. Then regarding AR and VR and stable diffusion, you can see the experiments by Scotty Fox that is kind of creating these VR environments where as you look around, basically the environment, the parts of the environment are being selectively replaced with stable diffusion generations, and it's all very experimental, but it's the beginning of what's going to come with virtual reality spaces produced with generative AI. And then we have NERF. NERF is a technique that already existed since a while ago, but is now becoming more accessible, and it allows you to use neural networks to learn a volumetric representation of a 3D space and then regenerate it, recreate it, and navigate all around. And I had a beautiful video here, but it doesn't allow me to show the video. But anyway, you can find it on my websites and whatever. But one thing to say about all of this, when people talk about the metaverse, this is like whatever is in the future. My opinion is that when the metaverse, whatever the metaverse is, because nobody agrees, but anyway, whatever the metaverse or the metaverses are and will become, in my opinion, they are gonna basically accelerate their their appearance thanks to generative AI, on the shoulders of generative AI. Basically, generative AI is what is going to accelerate the usefulness of something like the so-called metaverse. Okay, now limitations. Yes, there are a number of limitations that will be improving over time. Some examples: concept bleed. For example, you say, I want a yellow hat on the cat, and it puts yellow on the hat, but as you can see, it also puts yellow on the walls. Again, this is a problem of system 2, a lack of system 2 capabilities, because we are kind of brute forcing the system 1. And again, there is a question mark because we don't know where system 2 is how it works in the brain. So we don't know if by brute forcing system 1 further and further with the scale, etc., we don't know how far we will get with things that seem to look like system 2. In my opinion, we will need something else, but that's a big discussion. Okay, we ask for 7 bottles, and sometimes it puts 7, sometimes it puts 3 or 4. We ask for a face, and you see, again, the lack of precision is again a problem with lack of system 2 capabilities, and we don't notice this lack of precision if we look at a house or a landscape. But because we're very sensitive to human faces, we notice every little lack of precision with faces. Okay, but again, as we brute force system 1, this is improving and improving and improving. So just by scaling up system 1, this part is also getting better. Next. Oh, it doesn't pass. Little problem here. Oh, my slides. Okay, my slides have blocked. Have stopped working. My slides have stopped working. It doesn't pass to the next one. So let's see what I can do. Okay, can I maybe share the screen? Let's try. I'm going to try to share the screen. Okay, hopefully you can see now the rest of the landscape of the slides here. Okay, so the next thing is text. So these architectures are not basically optimized for text, but this thing is improving. Then the order. You see, I'm asking for a photo of a red apple on top of a green apple, and sometimes it puts the red on top of the green, and sometimes it does the opposite. Again, this is a problem with lack of system 2 capabilities, and again, weird combinations can give it trouble as well. But as we see in these 3 slides, from left to right, as we increase the scale, as we increase the number of parameters, you see how the generation in relation to the prompts that we see above, it increases dramatically. So again, there is this open question: is if by brute forcing system 1 capabilities, how far are we going to get with the qualitative improvements and with capabilities that may look sometimes like system 2 capabilities, but of course, a lot of people think that are nothing like system 2 capabilities, and this is all an open question. So to finish, what about us humans? Now that generative AI begins to take over creativity, what about us? Well, nothing, because nothing changes with our creative expression. Because for our mental health, key for our mental health is to have a good balance between our analytical and creative muscles. That is as important as before. It's as important as before to keep exercising our creative muscles. Same as when AI overtook chess players, we kept playing chess. We use AI to train our chess playing, but we keep enjoying playing with other imperfect humans. So it's the same thing. We are going to put these Iron Man suits to amplify our creative potential, our creative muscles, but with or without AI, we will keep exercising our creativity. We will keep looking for a good balance between our analytical and our creative muscles, because this is key for a good life and for a good mental health. So thank you very much. It has been a pleasure. And now we will open it for a few minutes of questions. So let's go back here.
Thank you, Javier. What a wonderful lecture. Very exciting to see the progress of prompt engineering. So as Javier mentioned, you guys can ask questions in the Q&A section. Currently, there are no questions, so let me ask you.
Yes.
We talked about prompt engineering and how it's going to affect the entire AI field. So how would you recommend someone um, to enter this field and to keep track of the prompt engineering skills?
Yeah, great question. Thank you, Noah. So, how do you get up to speed with prompt engineering? That is going to be so important from now on. Well, the first thing is that there are already a few people that have started to publish, small books or booklets about prompt engineering, and they are free to download. And the best way to actually find this is Twitter. Actually, Twitter is a little bit like the epicenter of AI, the AI community in many ways, in terms of finding news and the latest. So if you go around Twitter, you will find a lot of people referring to prompt engineering books and also giving advices. There are a lot of threads in Twitter where people have these long threads where they give advice about prompt engineering. This is currently the best way to get up to speed with it. Later on we will see people, publishing courses as well, and many other ways to get up to speed with it. Yeah. Let's see.
Thank
Do we
you
have
so
any?
much. We don't. Oh, I see questions. Okay. Sorry, I have a co-host, my 1-month-old baby. So I'm sorry for the noise.
You will be a master. Yeah, your baby will be a future master of engineering.
So we have a question. What are your thoughts on copyright when it comes to AI generated work? It's a very good question.
Yeah,
Coming
yeah,
from
that's a very
art
good question.
background, I feel like there are a lot of unresolved issues in ownership of
Yeah.
composite images.
Yeah, thank you for the question about the copyright. Yeah, as I wrote in my Medium article, I both work in generative AI and I am a creative artist as well, and I feel a great responsibility to support my fellow human artists. So for me, people come before technology, and but a lot of companies are very conscious about this already. For example, Shutterstock just said a couple of things. They said, okay, we're gonna incorporate generative AI into our platform, but we're also going to open a fund that is going to compensate those creators that whose works have been used to train these generative AI networks. So, the companies themselves, they realize, okay, we are building this revolution on the shoulders of artists whose works have been used to train these networks, and nobody has asked them for permission. Okay, so everybody's conscious about this, and companies are coming up, they are planning ways to compensate artists and creators for this. Now, in my opinion, there's still a big question mark. How exactly are they going to do it? How are they going to implement it? Okay, we are all waiting to see. We're all waiting to see what the large companies are going to do, about this, how they're going to implement it. But everybody's very conscious about this, about the need to compensate the artists whose works are being used to train these systems. Yeah, absolutely.
Okay, so there are no more questions. So thank you again for the amazing lecture.
Very
And we
welcome.
will
It's been a
see
pleasure. Thank you so much.
you.